In Outcome 27, you will learn how to solve quadratic equations. The first method of solving we will learn is graphing. Let's start with the example, x squared minus 10x plus 21 equals 0. The very first step is to rewrite your equation as y equals x squared minus 10x plus 21. In other words, we're just replacing this 0 with the y. So that's the first step. After you've rewritten it, you want to keep in mind that the equation is in the form y equals ax squared plus bx plus c, where a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. In other words, the number without a variable. We need to figure out what a, b, and c are in order to now find the vertex value, which we'll do by using negative b divided by 2 times a. So given this equation, let's take a look at what is the a value. What is the number right before x squared? Remember, when there is no coefficient there, no number there, that is by default a 1. What is the coefficient of x? It's negative 10. Don't forget to include that minus sign as a negative. So that is negative 10. And what is the c term? The c value is 21. Now, to figure out the vertex value, which is necessary to then begin to find the points we will be graphing, we need to first plug in a and b into the formula x equals negative b divided by 2a. So x equals negative, that's the very first thing. Make sure you bring over the negative sign. The b value in this case is a negative 10. So even though we brought this negative over, we need to write this negative 10 on top. In the denominator, we have 2 times, what is the value of a? The value of a is 1. Now let's begin simplifying. This double negative, you can now turn into a positive. In other words, that's just 10. 2 times 1 is 2. And now 10 divided by 2 is 5. 5 is the value, the x value of our vertex. That is very important. So to choose your x values, it's very important that in the second step, you now figure this value out and place that in the center of your table. So what are the two values that come before 5? 4 and 3. What are the two values that come after 5? 6 and 7. For this specific problem, we need to use those 5 values to graph our quadratic function, our parabola. In every problem, it's different. It all depends on the vertex value. It's very important you find that first to decide which values you will use. Now, let's go ahead and start plugging each of these values in one at a time. So we have y is equal to our x value, 3 to the power of 2. And I'll plug that into parentheses. That's especially important when you're using negative values. And this is being multiplied by 3 plus 21. So let's begin simplifying here. 3 to the power of 2 is 9. 10 times 3 is 30 plus 21. When you add these all up, 9 minus 30 is negative 21 plus 21 is 0. So the first point we can graph is 3, 0. 3 along the x, and we stay at 0 on the y. Let's continue. Y is equal to 4 to the power of 2 minus 10 times 4 plus 21. Y is equal to 16 minus, this becomes 40, plus 21. A little trick or shortcut, if you want to think of it that way, that I like to use is I like to add my positives first. So 16 plus 21, that's 37. And now I'll subtract the 40. 37 minus 40, that is negative 3. So let's plot the point for negative 3. For negative 3. Next, we have y is equal to 5 to the power of 2 minus 10 times 5 plus 21. So let's begin simplifying. 5 to the power of 2 is 25. 10 times 5 is 50. Let's bring down the plus 21. Again, if we combine the positives first, that's 25 plus 21. That's 46 minus 50 is negative 4. So let's plot the point 5, negative 4, 5, negative 4. Let's continue. Y is equal to 6 to the power of 2 minus 10 times 6 plus 21. Remember, if we're doing this correctly, in other words, if we've done these correctly, we should get negative 3 for this answer, and we should get 0 for this answer. But always complete the work all the way down in case you did make a mistake up here. But again, a good way of checking your work is this answer should be the same as this one, and this one should be the same as this one, assuming this is actually your vertex. So 6 to the power of 2 is 36. 10 times 6, 60, plus 21. Again, I combine my positives, 36 plus 21, that is 57. 57 minus 60, negative 3, as we should have got. So 6, negative 3. And let's do the final point. Y is equal to 7 to the power of 2 minus 10 times 7 plus 21. Y is equal to 7 to the power of 2 is 49. 10 times 7, 70, plus 21. Y is equal to 49 plus the 21. That is what? 70. And now 70 minus 70, 0. Let's plot the point 7, 0. We now have our quadratic, or the 5 points for our quadratic function, for our parabola. So I will begin plotting this. I noticed in a previous lesson, most students, or not most, but many students, graph their parabola and stop right there. Keep in mind, this continues, so just follow that pattern more or less as best possible. This is just a sketch, but as best possible, just follow that parabola, the direction, all the way to the end of your graph, and then put your arrowheads. That's just a reminder that this graph continues on forever. Now, what's new in this lesson from another graphing lesson is that we now have to figure out what the solutions are. 3 names for our solution, if you will. We have solutions, which is the same thing as x-intercepts, which is the same thing as zeros. So if you're ever asked in a problem, find the solutions, or find the x-intercepts, or find the zeros, you're really being asked for the same thing. So what are these? The solutions are where the quadratic, the parabola, crosses the x-axis. So hence this thing, the x-intercepts. So that point right there and that point right there happen to be our solutions, our x-intercepts, our zeros. So 3 and 7 are the 2 solutions to this quadratic equation.